Okay, dear students, after the break now, well, in the content of today, we have again an oblique surface, but the oblique surface is just the one. It is to create at the corner. Well, the associated surfaces, unfortunately, in the vicinity of the corner, they form the corner, are not perpendicular with respect to each other. Since the corner angle is not 90 degrees, then when we coincide x-axis, the y-axis will not coincide with the other edge. Since it is so, although we know the coordinates of the corner points along the edges, while we're creating the polyline, without making a calculation, cannot know the relative coordinate values to write. In such a case, we should know the coordinate of the corner point with respect to the corner along the edge. Not x, y, z values, but the location dimension of the corner of the oblique surface with respect to the existing corner of the body. What I mean? Okay, well, turn back to this example, and for instance, yes, over there, let me take a pointer into my hand. Well, the angle of this intersection with respect to this is, this angle is not 90 degrees. Okay, since it is so, when we coincide, for instance, x-axis with this intersection, then y-axis, it is orthogonal, will extend like this, will not coincide with this edge. Since it is not coinciding with this edge, it is going to determine the location dimension for the second point. Okay, this is the second point, for instance. With respect to where? With respect to origin, it is not easy cake. Since this edge is not perpendicular with respect to the other, we should use trigonometry, and then wasting time, indent can find the xyz values for the second point. This is impractical. This is too long. That is recommended in such a case. As the coordinates of the points with respect to this origin along this edge, learn or have the distance from the corner to the first point. Have the distance, okay, along the other edge relative to the origin. Have the distance along this edge relative to the origin. Not relative to the preceding points, relative to the origin. Mark the point, mark the point, mark the point. Using the given distance values. Along this edge, we know the distance. Along this edge, we know the distance. Along this edge, we know the distance. How it is done? In sequence, first coincide the x-axis with this edge and mark the first point using this distance. And then be able to coincide the x-axis along this edge, okay? And then mark the second point, coincide the x-axis along this edge, mark the third point. Okay, after marking the points, then can start the polyline process and join the points in sequence. Okay, then let's practice on such an example. Okay, move the coordinate frame to this corner. Okay, I'm going to mark the point, first point, second point, and the third point. Well, while this surface is being highlighted, or while this surface is being highlighted, or while this surface being highlighted, well, indicate the first point. It is this corner. While seeing the highlighted symbol, of course, make the click. And now the sense of the other coordinate axis is not important, because the important thing in this method is to coincide the x-axis along the edge. With the edge, along that edge, we have the point to mark. Okay. Coincide the x-axis, coincide the x-axis with this edge, coincide the x-axis with the other edge. Yeah, yes. Since in this method need to mark the corner points, well, there is such a preceding stage. Dear students, in engineering drawing, to mark the points, we use a tilted cross, not a dot, but a tilted cross. Okay, because in engineering drawing, dot means the projection of a tiny cylindrical feature. To say that it is a marker, it is a point, we use tilted cross. Okay, although it is under common agreement, in the default configuration of AutoCAD, point marker is a dot. It is wrong. Well, dot is the wrong marker in shape, because dot, although we put a dot for marking a point, it will look like a pixel point. You know, in the screen we have a grid, well, column wise and row wise located, lots of dots. These are called pixel point. Although we mark the point, since it will look like a pixel point, cannot see, cannot distinguish it. Okay, well, first pass through the teaching stage. Teach the software that the marker is not a dot, but a tilted cross. It is a format changing. First clicked on down direction, say not down direction, this listing arrow, it is along the quick access menu bar. Drop the list of the options, and if not yet, of course, well, select the show menu bar option, and then have the drop down menu bar, and along the drop down menu bar find format option. Clicked on the format option, and then drop this list in the down direction via which, and then select from the list point style option, and then, well, the selected point style is a dot. That is wrong. Well, corrected, selecting tilted cross. Size of the tilted cross is relative to the size of the screen. Relative to the size of the screen, 5% is a reasonable size order for such a mark. Okay, then say OK. After correcting the point style, by the way, such a configuration stage is to be repeated for each new session if you are using a MECH NCC classroom computer. You know the reason. And then, well, I'm going to mark the points one by one. Well, since these are to construct the oblique surface, to create the oblique surface in the end, it is, in general speaking, a construction stage. So, from the list of the transparent papers, well, select not object layer but construction layer. Okay, and then mark the points. Okay, first locate the coordinate system at the corner point. Relative to this corner, I know the location dimensions of the points. This is the origin, and indicate this characteristic point to coincide the x-axis. Well, the sense of the y-axis is not so important. Indicate any characteristic point. Why the sense of the z and y is not important? Because in the method, well, that stage is to mark the point along the edge, well, to which the x-axis coincides. Okay, start the point marking process. Where is the push button to start the process? Expand the drawing panel. Okay, and then over there at the expanded part, find this option. It says multiple points. To mark the points, we use this tool. With a click, start the process. And now, system asking the abscissa value of the point. Where is the point? Abscissa value in our example is 80. Okay, ordinate value. Well, for the point it is to mark along the edge. Ordinate is 0. Altitude is 0. Press enter. Yes, can you see along this edge there is a red color tilted cross. It is the first point. And then restart the coordinate displacement process, and then, well, indicate the corner as the origin, indicate this characteristic point as the second point along the positive side of the x-axis. Okay, y-axis, well, you may indicate one of the characteristic points, this one, that one. Not a matter, it is going to be perpendicularly oriented with respect to the x-axis. Okay, now restart the point marking process, and then, well, abscissa, only by using the abscissa value can mark the point. Well, the second point is along the along that intersection. Along the intersection we have the x-axis. Abscissa value for the the second point. You see, in this method we know the location dimensions with respect to the corner. These are given along the edge. Along the second edge, the distance from the point to the origin is say that 70. Okay, clicked on comma key. Ordinate is 0. Altitude is 0. Yes, distinguish the second point, and then press escape button, and then coincide the x-axis. Clicked on displacement button. Well, I'm going to coincide the x-axis along this edge, so while this surface is being highlighted or that surface is being highlighted, well, indicate this point as the origin and indicate this characteristic point as the second point along the x-axis. You see, I fixed the sense of the x-axis, while the y-axis indicate this characteristic point or that characteristic point, that characteristic or this characteristic point. Well, since the y and z values both will be 0, not a matter y-axis extending in which direction. Okay, be able to coincide xy plane with this surface or the other surface. Now I'm sure x-axis well coinciding with this intersection, and along this intersection I know the location dimension of the third point. Restart the point marking process, and then, well, system asking the abscissa value. Abscissa value is 120. You see, in this method, well, writing the coordinate values with respect to the origin, not with respect to the preceding the mark point, with respect to the origin. No need to consider the displacement, whether it is in the negative sense or positive sense. We are writing the coordinates, location dimensions, using abscissa value. It is always positive. 120. Clicked on comma key. abscissa is 120, altitude is 0, clicked on say ordinate is 0, clicked on comma key, altitude is also 0. Press enter. That is the third point. And then, well, the most difficult stage is overcome. That is okay, completed. The rest is polyline, 3D polyline. But here there is a trick. You know, if dynamic UCS is on, then well, can have one of the flat surfaces as highlighted. So in applying 3D polyline process, for having the boundary lines of the sketch, well, can indicate 2 points but cannot indicate the third point. It's an important trick, dear students. If dynamic UCS is active, is on, then can indicate 2 of the points but cannot indicate the third. We started polyline process. Okay, I have started the polyline process, and then, well, you see snap button, dynamic UCS button is on. I can indicate this point, of course, enabling nodes, select node option, enable nodes, node means point, okay, to snap. Okay, can indicate this point. For nodes, AutoCAD uses a green little circle with green tilted cross. Well, this is the first point I can indicate. This is the second point I can indicate, but third point, well, cannot indicate it. Unfortunately, be aware, third point cannot be indicated. So, well, the trick is that if you have the points to join with successive straight lines using 3D polyline facility, first don't forget to toggle off dynamic UCS button. Toggle it off and then start the joining process. To be able to easily see the points, I'm going to change the visualization style. Well, where are the points? Yes, first point, second point, third point. Well, repeat again, dynamic UCS is off. Toggle it off. And then can indicate the points without any difficulty. Well, point node option is selected. It is to enable nodes to snap the cursor. So everything is okay. Can start the polyline process, 3D polyline. And then, well, indicate this point while seeing the highlighted symbol, indicate this point. And then the first point one more time. Yes, you see, using indication technique, snap facility, I managed to create the boundaries of the surface. Okay, press escape button and then change the layer to object layer and apply the extrusion process. Indicate this region with a click, press enter, and then well, create the triangular prism. The length of the prism is not so important because, you know, it is to subtract from the rest. Okay, well, shed it with aids and then subtraction. Yes, start the subtraction process, clicking on this button, and then say that subtraction from this main part, press enter, that feature, press enter. Yes, you see, managed to create the oblique surface. Okay. Shoot the coordinate frame back to its vert location and then see the created surface. Well, the color of the metal, you know the trick. First drop this list, select warm cold phase style, and then one more time drop the list, select realistic option. Well, the entities for which already assigned the material, color is okay, it is in the color of the metal, but the last created surface need to repeat the assignment stage. Material browser, polished brass polished, hold it and drag it toward the surface, and then release the left button. That is it. That is okay. You see, created the oblique surface here, marking the points. Well, it's a poor practice to keep the points as visible in the screen. Well, see the advantage of creating the entities in different layers. Well, to be able to take the visibility of this red colored crosses, well, use the filter technique, drop the list of the names of the layers and then turn the length of construction layer off. Then, well, the content of construction layer will disappear from the screen. Okay, dear students, well, reached to the end of the class of today, session of today. Save the file saying classwork, save as classwork 6. Okay, in the content of today, and then, well, ending the video record, dear students. Okay, then, well, see you on next meeting, dear students. Bye bye. Ending this video record.